Good morning or good afternoon, everybody. Thank you for joining the live webinar on MeshGuard wireless detection. My name is Stephen Sao. I'll be your webinar moderator for today. Any feedback or comments regarding this webinar is greatly appreciated. Joining us today, we have the expert speaker, Jan Benducci, Global Product Manager for Fixed and Wireless Gas Detection Technology, to give us an insight look into the new advancements of MeshGuard. Before I turn it over to the expert speaker, let me show you how to submit questions and comments. In order to provide your feedback for the session or ask a question, please email us at events@raysystems.com or at our Twitter handle, #RaySystems. We will try to answer as many questions as we can during the live session at the end of the webinar today. And if there are still outstanding questions, we will get back to you with a response. This webinar is scheduled for 60 minutes. Please feel free to type in your comments or questions at any time during the webinar. And the Q&A session will be held at the end of the 60 minutes, or at the end of the 45-minute session. At this moment in time, I'd like to introduce Jan Benducci, Global Product Manager, to start us off. Jan?
All right, thank you, Stephen. All right, so today we're going to discuss the MeshGuard wireless gas detection system overview. Most of you folks in the room and most of the folks that are joining us online are already existing MeshGuard users. So we're going to, on the agenda, we're going to go, we're going to go a little bit quicker and say that we're going to do a little bit of a review about the existing product lines. We're going to talk about a little bit more about the system components. I think a lot of the folks are just using really the essentials, the basics of the product line. And we've got a lot more exciting things coming up in the future. So we're going to talk about what's new in 2012, what's available today, what's going to be available in the next couple of months. And then we're going to go into a quick cost analysis. A lot of the questions you folks have and the folks joining us via the web have a lot to do with the cost analysis. Why would I want to go wireless over a fixed system? So we're going to go through a little bit of an analysis on wireless versus fixed systems on the cost. Okay, so initially, what problem are we solving with MeshGuard? And traditionally what it is that fixed systems are bulky and the monitoring is heavy, there's cables, they're difficult to install. So this is not an issue for a lot of applications. I don't want to make this sound like we're going to fixed versus wireless, because I'm also the fixed product manager for Ray Systems. We sell fixed products as well. So they certainly have their place in the industry. A lot of really good applications. It's really the industry standard for a lot of applications. However, some of these issues in terms of the portability, the bulkiness, the deployment times, all of those things can be better addressed with a wireless system. So there's really some advantages in certain applications to go with a wireless system. So we're going to talk a little bit more about that as we go forward. Okay, so what's the solution? So essentially, we have a MeshGuard solution which allows us to be compliant and a cost-effective solution for safety needs in various industries. So as you can see on the screen here in the example, MeshGuard detectors are small, they're portable, they can be easily deployed. They talk not only to each other, but they eventually relay their information back to a controller, similar to a fixed system, where the controller is logging all the data and can provide alert notifications. It can provide data logging. It can actually push all of that data into another system or onto a network. So we'll talk a little bit more about that as well. Okay, so a quick review over the system. So I don't want to get too much into the details on this. Most of you guys are already familiar with the basics of the system, so we're going to kind of do a real brief overview over what's existing today, and then we'll spend a little bit more time on what's coming up in the near future, or some of the products that you may not be aware of that are compatible with the MeshGuard system. Okay, so the quick overview over wireless systems for Ray Systems is that we have a centralized software called ProRay Guardian that runs on a computer. It runs on a laptop or a desktop PC-based software. So that's really the center of our hub. From that hub, we can talk to what we're going to talk about today is the FMC controller, which talks to the MeshGuard system, talks to both our LEL detectors and our EC detectors, routers, echo views, other aspects of the MeshGuard system. But the key point of this slide is it's not only MeshGuard that's wireless at Ray Systems. All of our portable products, including the Ultra-Ray 3000, the Mini-Ray, the Multi-Ray, all of our other products are wireless or will soon be wireless. A lot of you may also be familiar with area rays. It's a lot of the same customer base as the MeshGuard system. So all of these different aspects of the wireless system all tie together on the same exact system running ProRay Guardian software. You can view not only MeshGuard, but also all of our portables, all of our area rays, all of our wireless products can all be seen on the same piece of software at the same time, all in real time. Okay, so MeshGuard, it's a turnkey system solution. That's really the crux of the wireless system. You want to have a complete system in a box that's easily deployable and cost effective. So the number one feature is they're compact, lightweight, and easily transportable. You can see by the picture on the slide that the entire system, you can fit 8 detectors and a controller all in one box. Everything is self-contained and very portable, easy to relocate for any of the particular applications you want to use it for. So it can be deployed in less than 30 minutes with no specialized training. So that's a really big differentiator between a wireless system and a fixed system, where you don't need specialized training. The system is you take them out of the box, you power them on, the mesh radios are smart enough to self-configure themselves, everything is up and going. So instead of having a specialist like you would need for a fixed system, someone who knows about the wiring, who knows about the controllers, this system is really take your detectors out, power them on, and deploy them. Everything's self-configuring, can be deployed, like I said, in less than 30 minutes, no specialized training required. It provides continuous detection and data transmission on a single battery for months at a time. So this is really why wireless systems are relatively new to the industry. Why hasn't this been done before? It really has to do with the technology. So in today's world, we have batteries and very low-powered radios and sensors that can be powered for 6 months at a time. Previously, with our portable instruments, or anybody's portable instruments, the battery life is somewhere between 6 hours and 24 hours. That really doesn't work if you need to do true 24/7 monitoring. So with low-powered radios, low-powered sensors, you can really do a 24/7 deployment without worrying about it. You can, again, swap the batteries every 6 months. We say 6 months. We have detectors in the field that go much, much longer than that. We're very confident in the 6-month battery life. You probably get closer to something like a year. Okay, and then the other thing to mention is they carry the same hazardous location certifications as traditional fixed heads. So you're not losing anything on the safety side. There's no compromise here. The exact same Class 1, Division 1, or for the international folks, we have ATEX Zone 0 on all of our MeshGuard products. So there's really no trade-off in terms of safety. And again, that has to do with the technology. The low-powered radios and the low-powered sensors have really enabled us to get the same safety certifications as traditional fixed heads. Okay. So a quick summary. Again, most of you folks are familiar with MeshGuard, so I don't want to go too much into the details, but just a quick summary of what the MeshGuard system does. So they are all wireless single-gas detectors. A complete system in a box can be deployed in less than 30 minutes. They are self-forming, self-healing wireless mesh network. And essentially what that means is the radios are smart enough to reconfigure themselves, and they always find the best path for the data to get from the detector back to your controller. So if a detector were to go down for whatever reason, then the other monitors in the system all reconfigure themselves in order to get the data back to the controller. Similarly, if you want to add detectors or remove detectors from the system, the wireless mesh network is smart enough to figure that out. So for one day you have 10 detectors, the next day you need 15. You simply turn on 5 more detectors and deploy them wherever you'd like, and they will automatically find the best path to get the data back to the controller. We have about 1,000-foot, 300-meter transmission range between detection points. So that's from a detector to the controller. Now, as many of you are familiar with, we also have routers, and also the function of the MeshGuard is that they can all talk to each other as well. So 1,000 feet point to point, but you can go multiple points. You can hop from one detector to the next detector, the next detector. Each one of those hops is 1,000 feet. We have 6 months runtime for true 24/7 operation. So this is on all of our electrochemical sensors. For the LEL sensor, it's really more of a power consumption issue. To get accurate readings, you need a lot more power running through an LEL sensor. So we have an external battery pack that runs 20 days. That can also be, we're going to talk a little bit more about, we have a solar option with that. So currently the power pack lasts 20 days with the LEL sensors. Again, we mentioned this before, but we have Class 1 Division 1 and ATEX Zone 0 certifications. So really what that means, in most applications, you can go anywhere. With Class 1 Division 2 or with ATEX Zone 1 or Zone 2 products, you really have to be careful about where you go inside of a facility or even on an outdoor drilling rig, for example. You have to be cautious of where you're moving the equipment. And with such a portable device as the MeshGuard, it's really a really essential feature that you have Class 1 Division 1. Because somebody can pick it up and move it to a new location, you don't have to have any fear about they're putting this in an area that's not designed for. You're putting the detector in an area that's more hazardous than what it's designed for. So again, with MeshGuard, you don't need to worry about that as you have the Class 1 Division 1 and the Zone 0 certification. And then finally, the controller stores all the data, and it has internal relays, so it can trigger lights, horns, process controls, any alert notifications you need to send out can all be done on the controller. Okay, so we'll talk a little bit more about the existing system components before we get into the new stuff. So essentially the essentials. So we have the detectors. Currently we have 7 flavors of sensors. We have LEL, H2S, CO, SO2, oxygen, ammonia, and chlorine. So those are currently the sensors we have available. We have others in the pipeline at your request. Our customer base has been asking us for other sensors as well, so we are actively pursuing the sensors on our customers' behalf. Again, the 1,000-foot transmission range, and again, the Class 1 Div 1 ATEX Zone 0 certified detectors. So the other essential piece of a system is the controllers. So we have the FMC 2000, which is the large metal box with the display. It supports up to 24 detectors. It has 5 internal relays. It also has Ethernet and Modbus output. The feature that we talked about a little bit earlier with the ProRay Guardian software. The controller can push all of that data out via Ethernet or even Modbus. Some customers prefer to have their own PLC system established at their facility. So we have a standard Modbus output that we make available to everybody. If you want to just take the data from our network and plug it into your own network, the controller is capable of doing that out of the box. And then finally, we have a RayMesh reader. So if you don't want to use the fixed system controller, then we have a smaller box device that connects to your PC, which is called the RayMesh reader. So if you want the data to go directly to your computer, the RayMesh reader can do that. Okay, so that's really the essentials, detectors and controllers. I'll talk a little bit more about the accessories, the other options that go along to round out the system. So quickly, the accessories. So this is the MeshGuard Power Pack. You can see it's an external battery. It's roughly 3 times the size of one of the detectors. This is really the only Class 1 Division 1 Zone 0 certified battery on the market. We had a real struggle making this thing, a real struggle getting it certified. But everything is certified. It's the only one, like I said, in existence. And the real key feature of it is that it's hot swappable in the field. So what that means is you can have detectors, you can have your battery. This goes for 20 days on an LEL detector. When it starts to get low, it'll give you an indicator that it's low wirelessly through the detector. You can simply take a new battery, bring it out there, unplug this battery in the hot zone, unplug it, put in your new battery, and then you take your old battery back for recharging. All right, so that's really the key feature, that it is hot swappable in the field, Class 1 Division 1 Zone 0 certified. So the other piece of another accessory is the MeshGuard router. So essentially, for those of you that are familiar with our routers, with our area array network, and also with the MeshGuard network, what this allows you to do is transmit distances further than the 1,000 feet that we spec it at. So if you want to transmit, let's say, 3,000 feet, you simply need to put out 2 routers. So you have a detector, you put a router out there, another router, and then finally it hops back to the controller. So essentially what it is it's a way to extend the range of your wireless network. The other function of the MeshGuard router, which we really try to push on people, it's actually included as a standard product in the kit, so I think most of you are familiar with it. The other function of the router is as a system deployment tool. So on the router, before you set up any detectors, you can walk around with the router, you press the button, and it'll give you the real-time wireless signal strength at that particular location. So what that means is when you're deploying a system, there's no question about, is it going to work here? I need a gas detector here. Will it work? Right? So before you deploy anything, you take the MeshGuard router out, you go to locations where you want detectors, you press the button at that location, and on the screen it'll say 60%, 70%, 80%. It'll give you the wireless signal strength at that particular location. So it's really a useful tool. It helps you, it can help save you a lot of time during a deployment and knowing exactly where the signal is. If you get a weak signal strength, then you simply know that you need to put an extra router out there. And then you put the router out there, you try again with the router, you press the button, and then it'll let you know if you've now increased your signal strength enough to where you have a reliable data transmission. Router is a really powerful tool. I think most people are just using it as an extension for their network, but as a system deployment tool, it can really save you a lot of time. Okay, the EchoView, this is relatively new for us. Within the last year, we released a product called the EchoView. One of the feedback that we got from our customer base, from you folks and the folks on the webinar, was that while the alarms are transmitted back to the controller, that's a nice feature. That's exactly what you would expect. But you don't want to have to be sitting next to the controller to be alerted to an alarm. So what we did is we created a portable device. It's the same form factor as one of the detectors, and it allows you to view the real-time data on your network through the portable device. So if any of these detectors on the system go into an alarm condition, then we know that this will be alerted as well. This will start beeping, the lights will start flashing. It'll tell you on the screen exactly which detector is in alarm. It'll give you the reading and the alarm condition, whether it's low alarm, high alarm, low battery. All the different alarm signals can be transmitted all in real time back to a portable device. And again, that portable device is also Class 1, Division 1 certified. So really the usage scenario is you're the safety manager at your facility. You don't want to be sitting in the room with the controller all the time. You have to go do your rounds. You have other work to do. You simply strap this thing on. You put it on your belt. You hold it in your hand. It's small enough to be portable. And you walk around. And if anything on your system, any of your wireless detectors go into alarm, you are then alerted wirelessly, wherever you are in the wireless network, alerted wirelessly to that alarm condition. Okay. And finally, we have an alarm bar. We have a hardwired alarm bar that attaches to our controller. So the controller has a built-in, as you guys know, a built-in light and a built-in siren. So those are relatively low powered. If you're in a room, it's fine. You can hear it. However, we know at a lot of industrial facilities or even in outdoor environments, sometimes those lights and that horn isn't loud enough. So we use the internal relays on here to drive very powerful lights and a very loud horn so you can alert a wider area and be more aware that there's something in alarm. Okay, so those are the basic accessories that we have available today. We're going to talk a little bit more, again, about some new stuff that's coming out. One piece we're going to talk about is, okay, now that you have the data onto your controller, we've established a network. You can send up to 24, you can send data from up to 24 detectors back to your controller. So once you have the data on that controller, now what? So we talked about you can get an alarm, you can get a light, you can get a horn. What else can you do with it? That's useful, but I want to be able to do more. So the first thing we talked about is that you have 5 internal relays. You can use those to drive lights and horns. We also know that a lot of you folks are using it to drive process controls, to turn on fans, to shut down processes, to do other things that are related to the safety measures. So those, the controller by itself has that built in as a standard feature. You have those relays that you can use to trigger different processes or alarm conditions. The other thing that you can do is you can send that data over a network. So not only the people at the facility are aware of those alarms and are logging that data, but you send that data over a network, and then anybody else that has a network connection can view that data all in real time using our ProRate Guardian software. So you can see the detectors on a map, you can see the history of the detectors, you can see the trends, you can see all sorts of information about the system that would be useful to you. And you don't have to be anywhere in the same vicinity as the actual detectors. So once it's on a network, one person can be in New York, the other person can be in Los Angeles, and they can view all that data in real time. Or even somebody could be in the Middle East, and then you have other folks in Houston. All of that data can be shared in real time if you configure it that way. You can also lock people out of the data. It's very secure in the way you're allowed to configure that data and how people can view that and who has access to that data. Okay, a little bit more about the software, the kind of the usage scenario. So what we've seen people doing with it, we know it's a very powerful feature. What we see is that somebody will have some detectors deployed. Let's say in this example, it's in an oil field, oil and gas drilling operation. They'll have detectors deployed in the field. They'll have the controller on the rig. And then once that data is on the rig, there's a divisional office that wants to view the data from that particular rig, not only from that particular rig, but multiple rigs. So you can be geographically separated. We know that in lots of those drilling fields, the pads are not that close together. So over a wide geographic area, you can have all of these different rigs sending all that data back to a divisional office. So this divisional office is managing all of those assets. It's not only viewing the alarms in real time, viewing all the data in real time, it's also storing a record of all the data log, all the information that's coming through is being stored and can be used at a later date for whatever reason they need to. So not only can you get that information through there using our software, but if there's a corporate office that wants to view multiple divisions, we know lots of the oil and gas companies are multinational. So if you have a corporate office, for example, that has operations both in Texas or in Pennsylvania, in the Middle East, in the North Sea, in Southeast Asia, you can have a lot of, a major corporate office can take all that information from those divisional offices and aggregate it in one place too. So instead of this manual task of aggregating all your data for your safety program, all that is done for you automatically. The software is grabbing all that data in real time, storing it all in one place, and so the corporate safety officers can have all that data aggregated in one place and have a nice record and be alerted to anything that's happening in real time. That's really the power of the software and our hardware that's enabling that by pushing that data both over an Ethernet system or over the Modbus. Okay, so that's it for the existing system. Hopefully I didn't get into too many details. We're making the assumption that you folks are existing MeshGuard users, have some familiarity with the system. So it was really just a brief overview. If you need more information on that, please feel free to email us. We have lots of information on all the details of those products we just talked about. We do want to spend a little bit more time about what's new in 2012, things that you may not be familiar with, things that are coming out in the very, very near future. So the first thing we want to talk about is a solar pack. So what this is we talked a little bit about the power pack's ability to power an LEL sensor. LEL sensor takes a lot more power to run. This power pack lasts for 20 days, and then it needs to be recharged, so you can go for another 20 days. So we understand that that was a logistics hurdle for a lot of people to have to go manually swap a battery every 20 days. What people were asking us for was a true 24/7 solution for LEL detection. So what we did is we came out with a solar panel, and it's not just any solar panel. It's actually a Class 1, Division 1, Zone 0 solar panel. Right, so this is actually the only one in the market. We would have loved to have just bought one of these from somebody else and plug it into our system. Unfortunately, it doesn't exist. We had to go build it ourselves. So we make this solar panel. Like I said, it's Class 1, Division 1, and Zone 0 certified. Same certificates as the power pack and the detector. So these things can go in the most hazardous locations without any concern for safety. So essentially, we can, it uses the sun's energy to charge the Ray power pack. It grabs sunlight from here, it pushes the power into the power pack, and then the power pack pushes the power to the detector. So the big question is how long will it actually last? And what we tell people, it really depends on your geography. So if you're obviously in the Middle East where it's sunny all the time, 24/7 operation, what we found is we have some customers in some very northern locations where the sun is not prevalent at all during the winter months. And what we found is they're actually getting 24/7 operation in the winter months. So we're very confident that this product, the solar pack, can provide enough energy to power an LEL sensor in almost every condition. Again, it's compatible with all MeshGuard wireless gas detectors and the mesh routers. So anything that has the form factor of this detector, so it's our MeshGuard detectors, it's the LELs, it's the ECs, it's it's the router, and it's the Echo View. All of those products are compatible with the Power Pack and the Solar Pack. And then, like I mentioned, it provides indefinite runtime for detectors in most locations. So we haven't found a location yet that doesn't get enough sunlight, but we can't say every location because there's some we know that really, really far north, they don't get any sunlight for 6 months at a time. But I can tell you we have customers in Canada and in the North Sea, in Scandinavia, no problems at all so far with the Solar Pack. They're getting true 24/7 runtime in their conditions. Okay, that's the Solar Pack. Again, we have, similar to our kits, we have the Solar Pack complete in one bundle. You can either have the Solar Pack as an addition to your existing system, or if you're ordering more components, you can fit the entire 24/7 LEL detection solution in one box. So again, going back to our portability, going back to the ease of deployment, everything fits in one Pelican case. So you have the, inside the case, you have the solar panel, you've got the battery, the power pack, you have the detector. We actually provide an additional charger just in case you need to charge up your power pack in addition to the solar pack. We have all the cabling, everything you would need to have a true 24/7 LEL detection comes in one case, in one bundled package. Makes it really easy to deploy, easy to store, easy to move around. So that's the Solar Pack solution that we've come out with. It's been released for about 4 to 5 months now. So we're starting to see really good adoption. The people who have it are very happy with it. If you need more information on this one, please let us know. We have lots and lots of detailed information about how the Solar Pack works, where it's been deployed, all the different things you would need to know. We've got lots of details, so please ask us if you're interested. Okay, the second thing we have a lot of feedback from our customers about the actual user interface on our controller. So right now it's very functional. However, we have a brand new major upgrade that we've done to the firmware of this product. We've taken all the feedback from the field, from you guys, from the folks that are joining us internationally. We've made a lot of improvements that are meant to ease the operation, to help you do your daily jobs, to help everybody stay in compliance, make the thing very easy. We're really big on having the system be very straightforward and no specialized training required. So the first major thing we've done is we've given you quick access to the last 10 alarms and faults. So the system previously had a data log. You could access that data log on your computer. You could see all the relevant data. However, what people were telling us was, I don't need all the data. I just need to know what the last couple of units that went into alarm were. So now we've added that. You press 2 buttons on the controller, and you'll see the last 10 alarms on your system. It'll tell you which detector it was, what the alarm condition was, and what the value of that alarm was, all for the last 10 of those alarms that were on your system. So we also have fully configurable relays and also added voting and zoning. So essentially what that is now you have 5 relays in there. You can set them to be whatever you want. They can either be high, low, fault, or common. Right, so you can have those 5 relays, configure them however you'd like. The other big feature we added was voting and zoning. So this is something that, if you're familiar with fixed systems, is fairly common in fixed systems. Essentially what that's allowing you to do is, for example, you have 5 detectors in one area and then 10 detectors in another area. You can say with voting, these 5 in this area, if one goes into alarm, I don't want it to do anything. That could just be a blip, a truck drive-by. It could be some temporary alarm. However, if 2 of my detectors in that area go into an alarm, then I want it to trigger a light, to trigger a horn, trigger a process control. If 2 detectors goes into alarm, it's a pretty safe bet that there's an actual incident that occurred. So this allows you to do that voting and zoning. You can say, I want to package these 5 in one group, and then if any 2 of those 5, or any 3 of those 5, any 4 of those 5 go into an alarm, then my relay will trigger. So really just add a lot of flexibility on how you can configure your system and your relays. And then finally, the configuration of this, you can see by the picture, and you guys are familiar with, the keypad looks more like, my easiest comparison is like an ATM keypad. There's 9 digits, there's a couple extra keys on there. So when you're typing in things like the location, the actual text strings, you're configuring your unit, it can take some time if you're not familiar with the system. If you're not a user who touches it frequently, it takes some time to configure the system using that keypad. So what we've done is we've allowed you now to configure that system, configure that controller via your PC. So now there's a config file that's on the SD card. You load the config file on your PC, and you can enter in all the information. You can fully configure your system via your computer. You save that config file, you load it back onto the controller, all through the SD card. All right, so it can save you considerable time. The other nice function with that config file is that if you have the same system deployed in multiple locations, let's say you have one standard setup that you have, and then you want to deploy it in different locations on different systems, you create one config file, and you can send that via email or however you want to move that file around, and you can load that same config file on multiple controllers. Right? So it really saves you a lot of time in terms of configuring the system. And finally, the other nice feature about having that config file is if you ever run into any problems, if your system is down and you need help, the easiest way to do it, instead of having somebody walk you through the interface on the phone, is you send that config file to either the distributor or your inside expert, or you can even send it to Ray Systems tech support. We'll look at that config file, and most likely we'll be able to tell you why it's not working correctly. We can modify the file. We can send it back to you and say, hey, load this back on your machine and see if this works. So instead of a 1 hour, 2 hour troubleshooting process, you've now reduced it to an email. Somebody else can configure it and send it right back to you. It really saves you a lot of time in terms of troubleshooting. And we know that that time is very important to folks who are actually running live operations. So if your system's not working, in all likelihood, you're shutting down whatever process or plant that you're working at. So this can really be a real lifesaver in terms of getting you back up and going in the quickest manner possible. So these are just the 3 major ones. We've got a slew of other enhancements we've made to the firmware. And again, we have lots of information on this. If you need more information or want more details about what upgrades we've made to the controller firmware, please let us know. Again, most of those changes have come at your request. So our customer base is fairly vocal in what they want, and we appreciate that. We want to make the system as easy to use as possible. So please keep giving us that feedback, and we'll keep making enhancements as necessary. Okay, finally, here's a new one that's not out yet, but it's coming out relatively soon. We're calling this one RayPoint. Essentially what RayPoint is, it's a wireless relay. So we talked about having routers deployed, detectors deployed. We have an echo view that gives you the information of what's an alarm. But really the major piece of feedback we have from you folks is that people want to have alarms in different locations. So not only at the controller, where we talked about you have the integrated light and horn, you can have a hardwired alarm bar, but they want to have alarms and process controls out in the field on the wireless network. So what we've done is essentially made a wireless relay. It has a mesh radio integrated into it. It has 5 relays inside of the box. It is Class 1 Division 1 certified, ATEX Zone 0, and those are pending. That's why it's not released yet. So though we have a very high confidence that will be released very, very shortly. So this is going to be a very powerful product for you folks in the field. The user does have to supply DC power, so it's not battery powered. But from our understanding, from what you folks have asked for, is if you have lights and horns and other things out in the field, you're going to need power for those anyway. So you'll have power at those locations. The relay, all of the signal cabling is not a factor because it's all wireless. And then we're expecting release in July of 2012 for this product. So a little bit more about the RayPoint. I'll give you a quick example if my description wasn't accurate or wasn't clear enough. Essentially, the relays inside of the RayPoint device mirror the relays that are inside your FMC controller. So we talked about all the logic that goes into the controller. You can do all the zoning, the voting. You can do all those things. You can assign each relay low, high, fault. Those configurations that are in the FMC controller and those relay triggers are just mirrored on the RayPoint. So all of that logic you have on the controller is still applicable to these remote relays. So essentially the quick example is, let's say one of your detectors goes into an alarm. So that detector goes into alarm, it sends that data immediately back to the controller. The relay on the controller triggers according to those configurations, however you've set up your relays to be triggered. And once those relays on the controller are triggered, it triggers the relays on the remote RayPoint. And those relays on the RayPoint can be connected to anything. In this example, we're using 1 horn and 1 light. But again, there's 5 relays inside of there. You can connect whatever you'd like to those relays. Our product, again, is intrinsically safe. When you start to connect other things, you need to make sure the devices you connect to it are intrinsically safe and that they're also certified for use, and the way you connect them through cabling or through conduit, those all have to be in compliance as well. But we do enable the ability to locate alarms and an alarm notification out in remote areas with a wireless connection. Okay, so that's the Ray Point. Again, you'll see, sorry to, my remote has a hair trigger on it. You'll see a lot more information about this coming up in the near future. We're going to do a fairly large press release. We'll have all the pertinent information, the data sheets, the manuals, the user trainings, all the things that we normally do for a product launch. You'll see that coming up in the next couple months. Okay, talk a little bit about the cost analysis, wireless versus fixed systems. Now again, you guys are already existing MeshGuard users, so I think you've already seen some of the benefits. There was a reason why you chose to do a wireless system over a fixed system. There's a lot of different ways to, a lot of different reasons you would possibly do that. One of the ones we get a lot of pushback on is cost. So people say, you know, oh, a fixed system is so much cheaper. For my customers, it's a lot easier. They're more familiar with it. So I want to do a quick run through of an actual cost analysis of a wireless system versus a fixed system. And again, in this example, we're not trying to say a wireless system is always better than a fixed system. So like I mentioned, we sell fixed systems too. There's always going to be a place for fixed systems. In certain applications, fixed systems are the perfect solution. That's exactly what you want. However, in certain applications, a wireless system makes a lot of sense, both from a convenience standpoint and also a cost standpoint, which is what we're going to talk about here. Okay, so I'm going to apologize in advance. There's a lot of numbers on this slide, so we're just going to quickly touch on the overall structure of what we're doing here. You can view the numbers while I'm talking, and we're going to not go into too much detail, but I think you'll get the idea at the end of the slide what the general point is. So whenever you're comparing a wireless system and a fixed system, you're going to have a cost of just the equipment. So you have your equipment cost. In our example, we're going to use 10 points. So 10 fixed heads versus 10 wireless heads. So in our example here, we're using just some rough numbers. This is actually a MeshGuard list price for a controller, MeshGuard list price for a detector. And then we're using some just general numbers for a fixed system, roughly $500 per head and $1,500 for a controller. So at first glance, when you, the end user, or you, the distributor, is looking at a comparison, you say, well, look, your wireless system that you're proposing is $22,000, but this fixed head system is only $6,500. It's clearly more cost effective to go with a fixed system. So that's just the equipment cost. What you really want to look at is your total installed cost. All right, so not only the equipment, but all the other costs that go along with installing a system. So in addition to the actual detectors and the actual controllers, there's additional materials costs. So if we say that each detector is located roughly 500 feet from the controller, right? So you have 500 feet from the controller for each wireless head, 500 feet for the fixed system. So on the wireless side, you don't need any other wiring or any other safety conduit. All of that's done wirelessly, right? So on the fixed head side, you have to do wiring both for both for the power and for the signal cable. And you also have to put that inside of some kind of safety conduit or cable tray or whatever else you may be using to meet your safety compliance. So we've used these costs here of 90 cents a foot for the wiring and $1.10 for the conduit costs. I know those prices vary by region, both here in the U.S. and internationally. Those prices can be all over the map. So I think you'll see whatever prices you want to use in your comparison, I think you'll still come to the same conclusion. We've done this analysis in different regions of the world. It always comes out with the same answer at the very end. So if you don't like the numbers we're using, please put in your own numbers, do the math, and you'll see that the end results are the same. So you're saving roughly $10,000 on this example in additional materials costs. The other piece of it is the installation labor costs. So when you look at a wireless system versus a fixed system, there's an installation time per sensor head, and there's a labor rate. There's also the installation time for all that cabling and all that conduit. So on a fixed head, we're roughly estimating $200 for the complete, for the wireless side, we're estimating roughly $200 for the installation cost. And again, that's really opening up a box, turning on the units, walking them out to wherever you want, turning them on, and then you're done with the system, you're done with your deployment. That's how easy it is. It's less than 30 minutes on a wireless system to deploy the whole system. Now on the fixed system side, you've got a little bit more. Each head has to be hardwired in for power. You also have to run this cabling for the power, and the conduit is actually a big expense too. A lot of scenarios, you have to dig trenches, you have to put them in cable trays, you have to mount things so that they're out of the way, they're not tripping hazards, they're not in the way of other processes, they're not blocking roads. There's really a lot of complexity in installing a fixed system in terms of the actual cabling and the safety aspect of that. So when you look at the installation labor cost, there's a huge number associated with a fixed system. Most of that is safety related, like I said, the cabling and the conduit. So you really have the speed of deployment really brings down your cost of deploying a system. And this is really a one-time deployment for the fixed system. If you want to move that all around, if you want to change the location of a head, you want to change the location of your controller, you got to rewire a bunch of stuff. On our system, you can move it at will, right? So it doesn't take you, it'll take you another $200 to go out there, have one guy rearrange your system. Everything's wireless, so there's really not any labor time involved. And again, it's not even skilled labor, right? You can have anybody go out there and do it. Whereas on a fixed system, you have to have a specialist, usually an electrician, a technician, somebody who knows what they're doing in terms of wiring and system configuration. Okay, then finally, there are battery replacement costs. So on a wireless system, again, the batteries do have to be replaced. We're using an estimate of once every 6 months. The total cost for 5 years of batteries on a 10-point system is roughly $3,500, including the labor rate, including the batteries, including the cost of everything. So $3,500 over a 5-year span. Whereas on a fixed system, there's nothing. You have your hardwired power, it's there. You never have to replace batteries. There's no labor costs involved. So it's really a zero for a fixed system in terms of battery replacement costs. Okay, so when you add up all these different things, the equipment cost, the additional materials cost, installation labor costs, and the battery replacement costs, what's the final sum? So you can see that on a wireless system, it's roughly $26,000 for a totally installed wireless 10-point system. And on a fixed system, you're up at $55,000. Right? So on a total cost per head is $2,600 for a wireless head installed, $5,500 for a fixed system head installed. So now if you go back to the initial estimate when you're looking at a price comparison, you had a $22,000 versus $6,500, so it looked like a fixed system was a lot more favorable. However, when you take into all the other accounts, you're looking at $26,000 versus $55,000. So a quick other way to look at it, that same exact example, the 10-point example, $55,000 on the fixed head side. What you'll see is that when you break it down, you've got your initial equipment cost, which was 12%. You've got additional materials cost, which was 18%. That's the cabling, the conduit. And you've got this really big piece of installation labor cost, 70%. And again, that's going to vary by location. We understand that the labor rates we used, the example we did was for the US. Globally, those rates are different. But again, I would encourage you to put your own numbers in there. We've done this scenario for almost all the regions that we sell in, and the results are very similar no matter what you do and which region you're in. Okay, so when you compare that to a wireless system, on the wireless system, you've got a big chunk for the equipment cost, 41%. But you've got zero additional materials, you've got a 6% for your battery replacement cost, and your installation labor cost is very minimal, less than 1%. And so what that equates to is your wireless cost savings, 53%. Your 53% savings when compared to a traditional fixed system. And again, this is for that 10-point example. So as I mentioned, if you want to use different labor rates, different prices for the conduit, different prices for the cable, you may not get 53%, but you're still going to get 20, 30, 40%, maybe even 60, 70, depending on which countries you're in. So again, I would encourage you to do the math yourself, but you'll always come out with a savings on the wireless side due to the ease of installation and the lack of additional materials, no cabling, no conduit. Okay. So the other thing to mention that we talked about a little bit is when something goes down, when you have downtime. So everybody knows who's using MeshGuard, if your system goes down, you have to shut down a process or shut down a drilling rig, for example. That downtime equals real money. So we've had estimates from our end users that say when a rig goes down, a drilling rig, it can be anywhere from $5,000 to $50,000 per hour when the system goes down. So we're going to use $20,000 for this example. So let's say one of your detectors goes down for whatever reason. It's hit by a truck, There's some circuit board that failed for whatever reason. So with a fixed system, you need to have an electrician come out there and fix that, right? You gotta shut down the system, unplug, undo a bunch of conduit, undo the cabling, replace that head, put it back together, restart the system, make sure everything's configured correctly, bump and calibrate. So we estimate it's roughly 4 hours to do that if a head goes down. On a wireless system, you just take another one out of the box, walk it out there, put it in place, take the defective one or the one that went down and take it back out of the field. The system reconfigures itself automatically. There's really zero time involved in that. It's a very similar thing for the sensor replacements. Everybody who uses gas detection knows that sensors go bad, whether it's because of the life of the sensor, there's a limited life on them, or if they get overranged, or if they're exposed to something that might poison them. So sensors go down in gas detection systems all the time. So the cost of replacing that sensor is also an issue when you're talking about downtime. So we've estimated it's roughly 2 hours to replace a bad sensor on a fixed head. And again, on the wireless side, it's the same scenario. You can go back into the office, grab a new detector, put it out there, take your old one back in, and replace the old one at your leisure while the new one is already up and going. And then finally, it's the same thing with calibration. So calibration is just a required part of accurate gas detection. So typically when you're calibrating a fixed system, there's usually a mode on the detector where it allows you to tell it that you're going to calibration mode, or you have somebody at the controller disabling the relays, the alarm settings while you're calibrating. So in essence, you still have to shut down your system. You're not actively monitoring the safety while you're calibrating. So there's a downtime associated with that calibration. And again, on the wireless side, you don't have to do that. You can calibrate in your office with a spare detector. You take that freshly calibrated detector, walk it out to the field, replace the one that needs calibration, bring that one back inside your office, and you can calibrate it at any time you want. There's really no downtime involved in that. So in addition to the actual cost savings of the system that's being deployed and all those things we talked about on the previous slide, these numbers are much, much larger than the cost of the system. So that downtime is really, really important. And the benefit of wireless is that the system is so flexible, it can reconfigure itself, that you don't have to, that the downtime is minimized with that. And often these costs are much, much more than the actual cost of the equipment itself. So it's really important to have that flexibility, and it does create real cost savings because of that flexibility. Okay, so this is my final slide. This is the MeshGuard system summary. Okay, so we have a complete system in a box that can be deployed in less than 30 minutes. We talked about all the advantages of being able to rapidly deploy systems, and all that, the flexibility that brings and all the cost savings that brings. It's continuous detection and transmission for months on a single battery. It's the same level of hazardous location certification as any of your traditional fixed heads, Class 1, Division 1, and ATEX Zone 0. There's no specialized training required for deployment, so you don't have to go through repeated trainings. Anybody can take a unit out of a box, press the power button, and the system is up and going. No specialized training required. And again, we talked at length about the significant cost savings versus fixed systems, primarily due to the low installation costs and the reduced system downtime. Okay, that's all I had. Hopefully this was beneficial to you guys. We did a quick review. We talked a little bit about what's coming up next, and we did a quick cost analysis. If you need any more information, please feel free to contact us here at Ray Systems. And I'll turn it back over to Stephen.
Thank you for that, Jan. At this moment in time, I'd like to remind the audience to submit your questions to the email address events@raysystems.com or at our Twitter handle, #RaySystems. I also wanted to note that the recorded session of today's webinar will be archived on our website in about 2 weeks or so. By the way, Jan, I did receive some questions throughout the entire webinar, and I'll pose them to you right now if you don't mind.
Okay.
Is CSA approval required on the MeshGuard system?
So it really depends on your application. That's a very good question. So as we mentioned, you heard me mention multiple times what our certifications are. So most customers who deal in hazardous locations will require either CSA or UL. Those are typically the two certification agencies for North America. And you have ATEX and you have IECX for other regions of the world. So typically people who deal in hazardous environments will require CSA or UL certification. However, there are some applications that are non-hazardous, things like oxygen, for example, even some of like the low levels of H2S or ammonia. They're not hazardous locations per se, so they may not require that. But as a standard, all of our MeshGuard products are CSA certified, Class 1, Division 1, and also ATEX Zone 0.
Excellent. That's definitely great information to have. Another question I received is, how do you maintain the accuracy of the data? For example, bump testing the remote ECs.
How do we maintain the accuracy of the data?
So how do you do a bump testing on kind of the remote systems if you can't get to them?
Okay. So for bump testing, you physically have to be at a detector, right? So one of the things that I mentioned, so the sensor is in some remote location. You either physically have to walk out there and bump it. The other option that you really have with a MeshGuard system is that you have extra detectors in your office in the safe zone. You can calibrate and bump a detector in your office in a safe area, take that detector, walk it out to the location, and swap it with the one that you think needs to be bumped or calibrated. So it's really like however long it takes you to walk to that or drive to that system, you can bump and calibrate elsewhere and then swap the detectors very easily. You don't have to worry about reconfiguring the system. The radios are smart enough to, within fractions of a second, realign the system when you swap a detector in and out.
Great answer. And just as we were talking about bump testing and calibration, I got some questions regarding how do I find correction factor charts and how do I make them accurate to the substance I am measuring? Maybe this is a redirection to someone else inside the company?
Yeah, no, that one we can do. So typically we do a lot of correction factors for our PID products. So we don't have a PID enabled MeshGuard, but we have an LEL detector. So right now, most of the applications we're seeing are for methane. And so our unit is bumped and calibrated to methane. However, you can apply a correction factor on an LEL sensor as well. So assuming you're looking for pentane or some other explosive or flammable gas that you're looking for, you can apply a correction factor inside the detector, and it will then display that reading of that target gas, even though you've already calibrated to methane.
Great information. Some of our viewers are interested in solar packs. So one asked, tell me more about how solar pack works. Where can I use this?
Okay, yeah, so the solar pack is really an enabler for a lot of different applications. People who need LEL monitoring, but they don't want to have the burden of swapping that power pack every 20 days. So typically in an unmanned location or someplace that is resource constrained in terms of their personnel and how often they can how much time they can dedicate to doing that. So really what the solar pack does is it's a solar panel like any other solar panel. And the way those work is obviously they have to be pointed at the sun. So in the northern hemisphere, you want to make sure it's pointed south. And you also want to tilt the solar panel to the latitude that you're at to maximize it. So really solar panels, there's a really big effect on solar panels and how they're deployed, physically how they're deployed. So you want to make sure it's facing the correct direction, which is south in the northern hemisphere. And you want to make sure that it's tilted at the right angle. And so obviously you don't want to have it in the shade or under a roof or in a building. It has to be exposed to the sun. But we found, like I mentioned, that if it's deployed in the right way, if it's deployed facing the correct direction and tilted at the right angle, we found that it provides more than enough power in even some of the most difficult climate conditions that we've come across. So it's really a question of how you deploy the system, making sure that it's not in the shade and making sure that that you have the right angles and the right orientation of the panel.
Speaking of climate conditions, we just got some more questions regarding, can you tell us more about the temperature range that the MeshGuard can operate in?
Okay, yeah, so we spec with really the temperature limitation comes on the battery technology. So we mentioned that one of the reasons we're even allowed to do MeshGuard these days is because we have some really good low power radio technology, we have some low power sensor technology, and we have some really good battery technology available to us. And so those three things have kind of come together in the last 5 to 10 years and allowed people to make detectors like this that can be used in hazardous environments. So really the limitation on the temperature comes from the batteries. So the answer to Stephen's question, or whoever posed the question, was that with the internal battery, our spec is down to minus 20 degrees, minus 20 C, which is minus 4 F. So it's really minus 20 with the internal batteries. However, with our external battery, that power pack that we talked about, again, remember, it's typically used with the LEL system. It can also be used with the electrochemicals. That power pack, it has different battery technology, so it can actually go down to minus 40. So the quick summary is, with the power pack, everything goes down to minus 40. With the internal battery, everything goes down to minus 20 C.
Oh. And in terms of kind of the signal range, what is the maximum range we can transmit signals from MeshGuard to the controller and using routers as well?
Okay. So we've spec'd it out at 1,000 feet or 300 meters. And for those of you familiar with array systems, we're very conservative on how we spec these things out. So we know that it goes much further than that. That's a real world scenario distance that we give. That's a number that we're very comfortable with speccing to people. So that's intended for use in, say a refinery, an industrial environment, out on a rig. There can be objects in the way that we say, okay, you can still go 1,000 feet. If you have a pure line of sight to the controller, you can go much further than 1,000 feet. So we spec it at 1,000 feet, 300 meters. The maximum you'd probably get is something like, we've seen it go almost a mile, actually, in ideal conditions, right? Which is not likely where people are using these detectors. In ideal conditions, you go roughly about a mile, or what is that in meters? That's like 5,000 feet. That's like roughly 2 kilometers, right? 2.5 kilometers in ideal conditions. And then the other thing that you mentioned is that's point to point. You can use routers. So every time you add a router to the system, you essentially double the distance. So we say 1,000 feet, you put one router in, now you're at 2,000 feet. You put 2 routers in, then you're at 3,000 feet, right? So the maximum we can do is 3 hops. So you get, our maximum spec would be 4,000 feet would be what we would be comfortable saying, 4,000 feet. Now again, like I mentioned, the radios can actually transmit much further depending on your deployment scenario, but 4,000 feet would be the number we are comfortable, very comfortable giving out to people.
Sure, sure. We have 2 minutes left, and we're still getting tons of questions coming in, so I'll just have you answer 2 more. The first one is there an infrared sensor available for LEL detection as an option to catalytic bead sensing technology? Also, are there plans to offer PID in the MeshGuard configuration for the future?
Okay, so first on the LEL one. So in today's product line, we do not have an infrared sensor for LEL. They do exist on the market. Some fixed heads have them. Essentially, we made a decision to go with our standard sensing technology. It's really, there's some advantages that, I don't get into the details, there's some advantages to going with a catalytic bead sensor versus some infrared sensors. However, those do exist, and we have been looking at them. So we wouldn't say that no, we would never do it, but in today's world, we only have catalytic bead, and if somebody wants more details on that, please feel free to email us. We can give you the advantages of a catalytic bead over infrared sensors. And the second one was on with regards to PID.
In MeshGuard, yes.
Yeah, so PID is a little bit of a bigger challenge for MeshGuard in that the PID typically, a lot of people are familiar with it from handheld devices. Really what you run into on PID, just in terms of the technology, is over time the units start to drift, right? So if you really want to run something for 24 hours, 7 days a week, 365 days a year, there's really a concern with drift, especially on a PID sensor. Now we do have fixed head PIDs that we use. However, the technology inside of those is it takes a lot of power to run them, and it's also physically a lot of space. So to put it on a MeshGuard today is not feasible. However, there's a lot of advancements. As we mentioned, Ray Systems is kind of the leader in PIDs. We have a lot of patents. We have a lot of things in in engineering development. So I wouldn't say that we would never do it, but in today's world, we don't have a PID, and it's mostly because of the drift concerns over a 24/7 application.
Great. And final question and final answer. If an LEL sensor goes over 100% and stays in alarm until the unit is reset by the user, is there a way to remotely reset the sensor in this state?
That's a good question. I don't know the answer. There may be a way to do it on the controller. I'd have to get back to that person. I'd have to double check. There may be a way to do it from the controller, but I don't know offhand.
Great, that's fine. At this moment in time, I would like to thank our attendees for taking the time out of your busy day to join us on our webinar today. Please do not hesitate to contact your Ray Systems sales representatives or our distribution partners with any unanswered questions or comments that you may have. We hope the information from this webinar today will be beneficial to you, and we look forward to hearing from you soon and for you to attend future webinars. Thank you for joining us today.